Welcome to the Sauna Pod. I'm Ryan Alsberg, and this is episode 3. Today, we are diving into the fascinating world of your brain, the command center of your thoughts, decisions, and untapped potential. If you've ever wanted to sharpen your memory, elevate your intelligence, or unlock your brain's full power, this episode is a must listen. We'll uncover the secrets of neuroplasticity, the brain's remarkable ability to adapt, grow, and rewire itself, and how you can use this knowledge to take your mental capabilities to the next level. From boosting focus and memory to enhancing creativity, the tools and insights we'll share today could be the key to unlocking your cognitive potential and living a more empowered, dynamic life. First thing I want to do is say grace. I'm grateful. Grateful for the opportunity to speak, grateful for the freedom to make my own decisions, and grateful to be alive. For whatever that means, I truly don't know, but I'm thankful for it every single day. In this episode, we delve into key concepts related to brain development and mental fitness that can help you optimize your cognitive health and unlock your full mental potential. Here's a quick overview of what we'll cover. Full maturity of the brain. The brain continues to grow and mature throughout life, reaching full maturity in the mid-20s. This ongoing development means our ability to think critically, make decisions, and process information improves as we age, offering opportunities for lifelong cognitive growth. Types of intelligence. Fluid intelligence, the ability to solve novel problems, peaks in early adulthood, while crystallized intelligence, accumulated knowledge and experience, increases with age. Understanding these two types of intelligence helps us focus on areas that require different approaches as we move through life. Introduction to memory. Memory is fundamental to learning and decision-making. Understanding how memory works allows us to identify strategies to enhance retention, recall, and overall cognitive performance. Anatomy of the brain. The brain is composed of various regions, each responsible for specific functions. Understanding the brain's structure helps us see how different parts work together to shape our thoughts, emotions, and behaviors. Prefrontal lobe, the creative center. The prefrontal lobe is essential for creativity, decision-making, and goal setting. Engaging this area through cognitive challenges and creative activities can enhance executive functions, improving problem solving and critical thinking. Neuroplasticity, how it works. Neuroplasticity refers to the brain's ability to reorganize itself and form new neural connections. This remarkable ability allows the brain to adapt, heal, and continue to develop, regardless of age, underscoring how we can always improve our cognitive abilities. Wave energies and brain activity. Brain waves, such as alpha, beta, and delta waves, influence different states of consciousness. By understanding these waves, we can learn to manage stress, improve focus, and enhance mental clarity, improving overall brain function. Nutrients your brain needs to function at a high level. To function optimally, the brain requires essential nutrients such as omega-3 fatty acids, antioxidants, and vitamins, like B complex and vitamin D. A nutrient-rich diet supports cognitive health, improving focus, memory, and mental performance. Recommended brain exercises I like to practice. Puzzles, reading, and chess. Activities like puzzles, reading, and chess are excellent for stimulating the brain. These exercises can help improve memory, concentration, and problem-solving skills, preserving and enhancing cognitive function over time. Bonus content. How strength training affects the brain. Strength training doesn't just build muscles, it has profound effects on brain health too. From boosting memory to enhancing mood, strength training can stimulate the production of growth factors that improve brain function, memory, and overall cognitive health. Bonus content. How music affects the brain. Music has a powerful effect on the brain, improving mood, enhancing learning, and even stimulating creativity. We explore how different types of music can positively influence brain activity and cognitive performance. By integrating these concepts into your daily life, you can make small but impactful changes to support your brain's health and cognitive function. Simple practices like solving puzzles, reading, and playing chess can enhance mental clarity and memory, while strength training and listening to music provide additional benefits to boost cognitive performance. Over time, these habits can lead to lasting cognitive benefits. Remember, your brain is adaptable, and by taking proactive steps to understand how it works, you can unlock your full potential and lead a mentally sharp, fulfilling life. 1. Full maturity of the brain. The brain's journey toward full maturity is a remarkable process, one that takes place over many years and is influenced by a variety of factors. According to neuroscientific research, the brain matures in stages, with different regions of the brain developing at different times. These stages have been mapped out by scientists like Elizabeth H.S.L. Bonin, who examined the trajectory of brain growth, and Jay Geed, whose research is on the maturation of the brain in adolescence and young adulthood has been instrumental in understanding these stages. Let's break down the key phases of brain development according to science. Early childhood, 0 to 5 years. Rapid growth and synaptic formation. In the early years of life, the brain undergoes an explosive period of growth. By the age of 2, the brain is already about 80% of its adult size. During this time, the brain forms an immense number of synapses, connections between neurons, often more than it needs. Synaptogenesis, the formation of synapses, is particularly dense during the first few years of life. This is the brain's way of creating a wide array of potential connections in preparation for later learning and experience. This stage of development is crucial because the brain is soaking up information from its environment, essentially setting the foundation for everything from motor skills to language acquisition. The process of critical periods, first identified by neuroscientists like Huttenlocher, demonstrates how the brain is especially sensitive to specific types of stimuli during these years. For instance, early exposure to language or musical rhythm can significantly shape the neural pathways related to these functions. While this period is incredibly fertile for learning, it's also when the brain begins the first steps towards synaptic pruning, which eliminates connections that are unused or redundant, streamlining its structure. Childhood to early adolescence, 5 to 12 years. Expansion and refinement. As children grow, the brain continues to expand, but at a more balanced pace. The parietal lobe, which helps with spatial awareness and motor coordination, is particularly active during this time. This period of childhood is marked by a strengthening of the neural pathways that have been used regularly, improving skills like reading, math, and memory. The brain is becoming more specialized, and experiences and environmental factors play a significant role in shaping which pathways become stronger. By the time children reach adolescence, the brain undergoes a second wave of synaptic formation, particularly in areas like the prefrontal cortex and limbic system. This is when young people often experience bursts of creativity, curiosity, and an increased ability to learn complex subjects. However, this period also sees a dramatic increase in myelination, which is the process by which neurons are coated with a protective sheath, myelin, that speeds up communicating between brain cells. This wiring up of the brain enhances its efficiency, especially in regions related to basic motor skills, language, and memory. Adolescence, 12 to 18 years, the emotional and social brain. Adolescence is a unique stage in brain development. According to Jay Geed, who has conducted groundbreaking research into the teenage brain, the brain undergoes a restructuring during these years, specifically in the prefrontal cortex. responsible for reasoning, planning, and impulse control, and the limbic system, which governs emotions and social behaviors. During adolescence, the limbic system becomes more active, leading to heightened emotional sensitivity and, at times, impulsive behavior. At the same time, the prefrontal cortex, the area responsible for regulating these emotions and behaviors, is still maturing and struggling to keep up with the rush of feelings and experiences. This imbalance can explain why teenagers are more prone to risk-taking behaviors. They often seek new experiences driven by the emotional urgency of the limbic system, but they may lack the impulse control and foresight of an adult, which is still developing in the prefrontal cortex. While this phase can be turbulent, it's also a period where the brain begins to solidify certain social skills and emotional responses, though full emotional regulation is not yet fully in place. Young adulthood, 18 to 25 years. Fine-tuning and integration. As young adults enter their 20s, the prefrontal cortex continues to mature and integrate with other parts of their brain. This is the final stage in brain maturation, where the brain reaches a high level of functional efficiency. As Gede's research has shown, it's not until the mid-20s that the brain reaches its full maturity in terms of reasoning, impulse control, and emotional regulation. The prefrontal cortex becomes more connected to the limbic system, allowing for better emotional regulation, long-term decision-making, and the ability to delay gratification, skills that are essential for adult life, such as maintaining relationships, handling work stress, and planning for the future. During this time, the brain also undergoes further myelination, especially in areas linked to executive function, abstract thinking, and decision-making. The final stages of synaptic pruning also occur, eliminating inefficient pathways and making the brain's network more streamlined. This is when we see the greatest improvement in complex thinking, allowing for better judgment and more refined sense of self-control. The brain's final stages. The prefrontal cortex and emotional maturity. By the age of 25, the brain's prefrontal cortex has developed its full capacity for complex tasks like weighing the long-term consequences of decisions, controlling impulses, and managing social relationships. This is why, as we approach adulthood, we become better at managing stress, understanding the emotions of others, and planning for the future. While different parts of the brain mature at different times, the prefrontal cortex is the last to come into its own, influencing everything from career choices to parenting decisions. This final maturation is also shaped by life experiences. Exposure to diverse situations, education, and relationships all influence how the prefrontal cortex integrates with other parts of the brain, continuing to shape the way we think and feel long after the brain reaches its full maturity. In sum, the brain doesn't just grow up in a linear fashion. It undergoes several stages of development, each one crucial for building the cognitive and emotional skills we need as adults. These stages are influenced by both biological factors and life experiences, making brain development a highly dynamic and ongoing process. Understanding these stages provides insight into why we act the way we do at different ages and how the brain's intricate wiring continues to evolve throughout life. Synaptic pruning and myelination. Sculpting the brain. As the brain matures, it goes through two critical processes, synaptic pruning and myelination, which helps refine its structure and improves its efficiency. Synaptic pruning. Imagine a forest filled with countless trees, some of which are tangled and overlapping. Over time, the forest manager, your brain, comes through and clears out the excess undergrowth. Synaptic pruning is the brain's way of eliminating unused or less efficient neural connections. This happens especially during childhood and adolescence, when the brain is highly active and forming new pathways. The connections that aren't used regularly are pruned away, while the ones that are frequently activated become stronger and more efficient. This streamlining process helps the brain become more specialized, better at performing tasks. Myelination. Think of myelination as wrapping the brain's neurons in a coat of insulation. Just like how a wire is made faster and more efficient by adding a plastic coating, myelination covers neurons with myelin sheaths, speeding up communication between brain cells. This process happens in bursts, especially during childhood and adolescence, and continues well into the mid-20s. Myelination increases the speed and efficiency of signals in the brain, improving cognitive functions like memory, attention, and motor skills. It's why kids often struggle with complex tasks, but as they grow older, they become much quicker and more adept at handling them. Cognitive and emotional maturity, the brain's balancing act. As your brain matures, both your cognitive and emotional abilities undergo significant changes. Cognitive maturity. Early in life, cognitive abilities such as memory, attention, and problem solving develop rapidly. As the brain matures, reasoning and decision-making abilities come into play. The prefrontal cortex is the key player here, helping you to weigh options, plan for the future, and think abstractly. This is why adults tend to be better at solving complex problems than teens. Your brain's ability to make nuanced judgments and see the bigger picture strengthens over time. Emotional regulation. Adolescence is often marked by emotional turbulence, and that's because the limbic system matures much earlier than the prefrontal cortex. This imbalance can lead to impulsive decisions or emotional reactions that aren't fully thought through, but as the prefrontal cortex matures, it helps to regulate these emotional responses. By the time we reach adulthood, the brain becomes better at balancing emotions with logic, leading to improved self-control and emotional intelligence. Impact of genetics and environment, the brain's shaping forces. The development of the brain is not solely determined by age. Both genetics and environmental influences play significant roles. Genetics. Your genetic code provides the blueprint for brain development. It determines things like the size of certain brain regions, the speed of synaptic pruning, and even the speed at which myelination occurs. For example, some people are genetically predisposed to have faster processing speeds or better memory retention. However, genetic factors don't define your brain's potential. They just set the stage for how your brain can develop. Environment and life experiences. While genetics lay the foundation, the experiences you have throughout life shape your brain's growth. For instance, early childhood education, nutrition, exposure to new environments, and even the emotional support you receive can significantly influence how well your brain matures. Neuroplasticity, the brain's ability to reorganize and form new connections, is heavily influenced by your experiences. For example, children who grow up in stimulating environments with ample opportunities for learning often have a more robust, interconnected brain compared to those raised in deprived or stressful conditions. Even in adulthood, continuous learning and life experiences play a crucial role. Whether you are learning a new skill, facing a difficult challenge, or forming new relationships, your brain's structure can adapt and grow, supporting ongoing cognitive and emotional development. In conclusion, the maturation of the brain is a dynamic and complex process. It's shaped by a delicate balance between biological growth, life experiences, and environmental factors. While we may not realize it in the moment, the choices we make, the challenges we face, and the way we nurture our brains all contribute to how well we develop our cognitive abilities and emotional intelligence. By understanding these processes, we can make more informed decisions about how to care for our brains, whether it's through learning new things, practicing mindfulness, or simply allowing ourselves the time to grow into the full potential of our minds. 2. Types of intelligence. When we think about intelligence, we often picture a single, uniform ability to solve problems or ace tests. But as psychologist Howard Gardner proposed in 1983, intelligence isn't a one-size-fits-all concept. Instead, he introduced the theory of multiple intelligence, which suggests that there are different kinds of intelligences, each reflecting a unique way of thinking and interacting with the world. His theory expanded the definition of intelligence beyond traditional academic measures and opened up new ways to understand human capabilities. Let's explore these different types of intelligence and how they relate to brain maturation, all while weaving in scientific concepts that give us a richer understanding of our cognitive development. Howard Gardner's multiple intelligences. Gardner proposed that there are at least 8 distinct types of intelligence, each governing a unique set of skills. These include 1. Linguistic intelligence, the ability to use words effectively, whether in writing, speaking, or interpreting language. Think of writers, poets, and public speakers. 2. Logical mathematical intelligence, the ability to reason logically, recognize patterns, and handle abstract concepts. This type is often associated with scientists, mathematicians, and engineers. 3. Spatial intelligence, the ability to visualize and manipulate objects and spaces. Architects, artists, and navigators thrive in this domain. 4. Musical intelligence, sensitivity to rhythm, pitch, tone, and the overall sound structure of music. Composers and musicians exhibit this intelligence. 5. Bodily kinesthetic intelligence, the capacity to manipulate objects and use physical skills. Dancers, athletes, and surgeons are great examples. 6. Interpersonal intelligence, the ability to understand and relate to others, manage relationships, and communicate effectively. This intelligence is crucial for teachers, therapists, and leaders. 7. Intrapersonal intelligence, the ability to understand oneself, one's emotions, and personal motivations. Philosophers, psychologists, and spiritual leaders often excel here. 8. Naturalistic intelligence, the ability to observe, appreciate, and understand the natural world. Biologists, environmentalists, and gardeners have a deep connection to this intelligence. 9. Existential intelligence, a more philosophical and abstract type of intelligence dealing with questions about life, existence, and the universe. Think of deep thinkers or spiritual leaders. Gardner's theory gives us a framework for appreciating the diverse ways intelligence manifests across different individuals. But how does this relate to brain maturation? Let's break it down. Fluid intelligence, the brain's problem-solving power. Now, let's dive into the 2 primary types of intelligence from a cognitive perspective: fluid and crystallized intelligence. First up, fluid intelligence refers to the ability to reason, solve novel problems, and think abstractly. It's like the brain's flexibility muscle, allowing you to adapt to new situations and think on your feet. Fluid intelligence doesn't rely on prior knowledge, but instead enables you to process new information rapidly. It's the cognitive equivalent of a problem-solving ninja, quick, flexible, and creative. Fluid intelligence peaks in early adulthood around ages 18 to 25, a time when the brain is still highly adaptable and capable of forming new neural connections quickly. During this period, the prefrontal cortex, which handles executive functions like decision-making, reasoning, and problem-solving, is at its peak. As we get older, though, fluid intelligence tends to decline because the brain's processing speed slows down. This is partly due to neuroplasticity, the brain's ability to form new connections, beginning to slow after our mid-20s. Think of fluid intelligence like a fast-running river. In youth, it flows freely, adapting to every turn and obstacle with ease, but over time, the water flow slows and it becomes harder for the river to navigate new, unfamiliar terrain. Crystallized intelligence, wisdom through experience. On the flip side, crystallized intelligence is the accumulation of knowledge, facts, and skills gained over time. This is the stuff that grows as we live and learn. It's your internal knowledge bank. Crystallized intelligence doesn't rely on the ability to quickly solve new problems, but instead draws upon the experience and information already stored in your brain. It's like having a library of useful information that you can access at will. While fluid intelligence peaks in early adulthood, crystallized intelligence continues to develop throughout life. In fact, it can even improve with age, provided the individual stays mentally active, learning new things and engaging with the world. This makes sense when you think of the brain as having well-established pathways. Once a piece of information is stored in the brain, it can be retrieved relatively easily, even in later years. So while older adults might not be able to solve new problems as quickly as younger adults, they have a vast reservoir of knowledge and expertise to draw from. This is like the difference between a fresh, fast-moving stream and a deep, wide river filled with accumulated knowledge and wisdom. The deep river may not move as quickly, but it holds a wealth of valuable insights. Brain maturation and the balance between fluid and crystallized intelligence. The balance between fluid and crystallized intelligence is influenced by the maturation of specific brain regions. Let's break this down by age. Youth and early adulthood, 18 to 25 years. In this phase, fluid intelligence is at its height. The brain's prefrontal cortex is still highly adaptable and we can solve novel problems quickly. However, crystallized intelligence is still developing. Individuals are in the process of acquiring knowledge through formal education and life experience. The brain's plasticity allows young adults to quickly absorb new information and apply it in diverse situations. Middle adulthood, 25 to 50 years. During middle adulthood, there's a natural shift in intelligence. As the brain's plasticity begins to decline, fluid intelligence starts to decrease, and the focus shifts more toward crystallized intelligence. The brain becomes more specialized, and adults rely more on accumulated knowledge and experience to solve problems. This phase brings a richness of experience and a deeper understanding of the world. While we may not be able to learn new skills as quickly, we excel at applying learned knowledge and making informed decisions. Older adulthood, 50 plus years. In older adulthood, fluid intelligence may continue to decline as processing speed decreases and cognitive flexibility becomes less sharp. However, crystallized intelligence often remains stable or even increases. Older adults are able to make decisions and solve problems based on the wisdom accumulated through years of learning and experience. They may not be as fast in problem solving, but their decisions are often more deliberate and grounded in experience. How brain changes affect intelligence over time. The shift from fluid to crystallized intelligence reflects the brain's maturation and how we process new information versus use what we've already learned. Early in life, the brain is more about exploration and quick adaptation, thinking fast and learning quickly. As we age, the brain becomes more about refinement, applying what we know to navigate life's complexities. The gradual shift in these cognitive abilities doesn't mean that intelligence declines. It simply means that our mental resources change, adapting to different life stages. In summary, understanding the different types of intelligence and how they evolve with age can help us better appreciate our cognitive abilities at each stage of life. We all possess different strengths, and knowing how fluid and crystallized intelligence work together gives us insight into how we learn, adapt, and use our mental resources to succeed in life. Three, anatomy of the brain. Understanding the anatomy of the brain is like learning the layout of a grand city. Each area has its own specialized function, and these areas work together to keep the entire system running smoothly. From the grand avenues of thought to the quiet alleys of memory, let's dive into the key structures of the brain and how they function. Imagine the brain as an intricate network of highways, buildings, and stations, all carefully constructed to allow our minds to think, feel, move, and process the world around us. Here's a breakdown of the central regions and their roles. Cerebrum, the city's brain power. The cerebrum is the largest part of the brain, making up about 85% of its total weight. Think of it as the city's downtown hub, the center of all major activities. It's divided into two halves, or hemispheres, each responsible for different functions but constantly communicating to keep the city running smoothly. Left hemisphere, often referred to as the logical side, this hemisphere governs language, logical reason, and analytical thinking. It's where tasks like reading, writing, math, and problem solving happen. Right hemisphere, the creative side, we're responsible for spatial awareness, artistic ability, intuition, and holistic thinking. It helps us think outside the box, navigate the world around us, and process visual and spatial information. The cerebrum is also divided into lobes, each with its own set of responsibilities. Frontal lobe. Think of this as the brain's CEO. It handles planning, reasoning, emotions, and decision-making. It also houses the prefrontal cortex, which is critical for high-level executive functions like self-control and goal setting. Parietal lobe. This area acts as the sensory processing center, integrating information about touch, temperature, and pain from all over the body. It's also responsible for spatial awareness, how we perceive our bodies in space and how we can navigate the world. Temporal lobe, located near your temples, it processes auditory information and is critical for memory, emotions, and language. This is where the hippocampus, memory, and amygdala, emotion, are located, essential for storing memories and processing feelings. Occipital lobe. This is the visual processing center of the brain. It turns what we see into images and shapes, allowing us to interpret visual stimuli and navigate our environment. Cerebellum, the balance and coordination specialist. Located at the back of the brain, below the cerebrum, the cerebellum is like the city's traffic controller, ensuring everything moves smoothly without collisions. It's responsible for coordinating voluntary movements, posture, and balance. When you walk, run, or even pick up a cup, your cerebellum fine-tunes your movements to make them fluid and precise. It helps with motor learning and makes sure that when you pick up a tennis racket, your hand-eye coordination is spot on. Brainstem, the lifeline. The brainstem is the basic life support system of the brain, connecting the brain to the spinal cord. It controls essential functions that keep us alive. Things we don't consciously think about, like breathing, heart rate, and digestion. Imagine it as the power plant that fuels the entire city. Midbrain, the brain's communication hub, responsible for auditory and visual processing, as well as reflexes related to sight and sound. Pons. This area connects different parts of the brain, like a busy interchange, and regulates functions like sleep, respiration, and facial movements. Medulla oblongata, the city's emergency control center, managing vital autonomic functions such as heartbeat, blood pressure, and breathing. Limbic system, the emotional heart. The limbic system is like the city's emotional center. Think of it as the heart and soul of the brain. It governs our emotions, motivation, and memory, playing a critical role in how we react to the world around us. Amygdala. This tiny almond-shaped structure in the brain's emotional sentinel detects and processes emotions like fear, joy, and anger, and helps us react to emotionally charged situations. It's essential for emotional learning and memory formation. Hippocampus, the city's memory bank. The hippocampus plays a crucial role in forming new memories and converting short-term memories into long-term ones. It also helps with spatial navigation, remembering where you parked your car, for example. Thalamus, known as the sensory relay station, it receives sensory signals except smell and directs them to the appropriate parts of the brain. It ensures the proper routing of information. Hypothalamus, the regulatory center of the brain. It manages basic bodily functions such as hunger, thirst, body temperature, and hormone release. It's also involved in regulating emotional responses and behaviors. Basal ganglia, the movement and reward center. Deep within the cerebral hemispheres lies the basal ganglia, a group of structures that regulate movement, learning, and motivation. Think of it as the brain's reward and habit system. Caudate nucleus and putamen. These structures help control voluntary movements and fine-tune motor actions, ensuring smooth coordination. They are involved in habit formation, from riding a bike to brushing your teeth. Substantia nigra produces dopamine, a neurotransmitter essential for movement and pleasure. Damage to this area is famously linked to Parkinson's disease, affecting motor control. Corpus callosum, the bridge between hemispheres. The corpus callosum is the superhighway that connects the left and right hemispheres of the brain, allowing them to communicate and share information. Without this bridge, the two sides of the brain would function like isolated islands, unable to share ideas, emotions, or information. It's essential for tasks that require both analytical thinking and creativity. Ventricles and cerebrospinal fluid, CSF, the brain's cushion. The brain is surrounded by a protective layer of cerebrospinal fluid, CSF, which fills 4 interconnected cavities called ventricles. This fluid acts like a cushion, protecting the brain from injury while providing nutrients and removing waste. The ventricles help maintain a stable environment for the brain to function smoothly like an airbag, keeping everything secure. Pineal gland, the sleep regulator. Located near the center of the brain, the pineal gland is responsible for producing melatonin, a hormone that regulates the body's sleep-wake cycle, and it ensures you feel sleepy at night and awake during the day, keeping your circadian rhythms in check. Pituitary gland, the master gland. The pituitary gland, often called the master gland, is located at the base of the brain. Despite its small size, it has a big role. It releases hormones that control growth, metabolism, reproduction, and more. It's like the brain's very own chief of operations, making sure that everything runs smoothly in the body. Wrapping up, the brain is a beautiful, intricate network of structures, each playing a vital role in our cognitive and emotional lives. From the cerebrum, where thoughts and ideas spark, to the brainstem, which ensures life-supporting functions, each part of the brain is like a specialized department in a busy city, working in harmony to keep us alive, alert, and engaged with the world. But beyond these key regions, the brain's structure itself, the very texture of its surface, adds another layer of complexity. The brain's gyri and sulci, those folds and grooves, aren't just wrinkles. They are like a roadmap that organizes and maximizes the brain's capacity to think, process, and react. And the difference between gray and white matter is like comparing the brain's processing hubs to its communication highways, each essential to making our minds function at their best. By understanding these features, we can deepen our appreciation of how the brain works together as a whole, coordinating everything from deep emotional responses to complex problem solving. It's this dynamic interplay between structure and our function that shapes who we are, our ability to think, move, feel, and learn. Gyrus and sulcus, the brain's textured surface. Imagine the brain's outer layer, the cortex, as a wrinkled map. The folds and grooves that give the brain its characteristic look aren't just for show. They serve very specific functions that allow our brain to pack more neurons into a compact space, increasing its processing power. These folds are made up of gyri and sulci, which, despite their simple names, play a huge role in how the brain processes information. Gyri, plural for gyrus, are the raised, rounded ridges of the brain's surface. Think of them as the peaks of a mountain range. Each gyrus plays a part in processing different types of sensory and motor information. The precentral gyrus, for example, controls voluntary motor movements, while the postcentral gyrus is involved in processing sensory information from the body. Sulci, plural for sulcus, are the valleys or the grooves between the gyri. If the gyri are the peaks, the sulci are the valleys that create spaces between them. These sulci are just as important because they divide the brain into functional regions and provide more surface area for the cortex. The central sulcus, for example, is a key groove that separates the frontal lobe, responsible for motor functions and higher cognitive functions, from the parietal lobe, which handles sensory processing and spatial awareness. These folds aren't just a cosmetic feature, they increase the surface area of the brain without making it larger. It's like folding a piece of paper to fit more writing on it. The more folds, the more neurons the brain can pack into a relatively small space, enhancing its ability to process and store information. Gray matter versus white matter, the brain's highways versus its power plants. When we look at the brain, we encounter two different types of tissue, gray matter and white matter. They may look similar, but each has a distinct role in brain function. Almost like two different kinds of workers in a large organization, one responsible for thinking and decision making, and the other for communication and coordination. Gray matter, the brain's information processors. Gray matter is where the brain does its thinking. It's made up of the cell bodies of neurons, the part of the cell where the nucleus and the other vital components are located. Think of gray matter as the brain's office building, where all the cognitive processes, thinking, learning, memory, and decision-making happen. It's the site of synaptic activity, meaning that this is where neurons are actively firing and communicating. Location. Gray matter is mostly found on the outer surface of the brain, the cerebral cortex, but also in deeper structures like the thalamus and basal ganglia. Role. Gray matter is responsible for processing sensory information, controlling muscle movements, and executing higher functions like reasoning, planning, and memory formation. It's like the central hub where all the brain's major decisions are made and where thoughts are born. White matter, the brain's information highways. In contrast, white matter consists primarily of myelinated axons, the long, thread-like extensions of neurons. These axons are coated in a fatty substance called myelin, which acts like insulation on electrical wires, allowing signals to travel faster and more efficiently. White matter connects different regions of gray matter, forming a communication network that ensures the different brain areas can work together harmoniously. Location. White matter is found deeper in the brain, beneath the gray matter. It connects distant regions of the brain and spinal cord. Role. White matter's job is to carry information from one part of the brain to another. It's like the highways that connect cities and allow traffic to flow freely. Without white matter, the brain's different areas would be isolated and unable to coordinate properly. White matter also plays a role in cognitive processes like learning and memory. As we age, we naturally lose some white matter, which can affect cognitive speed and processing power. Why do gray and white matter matter? To understand the interaction between gray and white matter, imagine you're running a business with multiple departments. The gray matter is your decision-making office where all the important work happens. The white matter is like your communication network, linking the departments together and ensuring the information flows quickly and smoothly without good communication. White matter. Your department's gray matter would struggle to coordinate. Similarly, without the processing power of gray matter, your information would be meaningless, no matter how quickly it's transmitted. Here's a fun fact. In healthy brains, the ratio of gray to white matter changes as we grow. As we mature, our white matter increases, allowing for faster and more efficient communication between brain regions. This is why we become more skilled at solving complex problems and processing information as we age. However, too much white matter loss due to aging or neurological conditions like multiple sclerosis can impair cognitive function and motor coordination. Interplay between gray matter, white matter, and brain health. Gray and white matter are both essential for maintaining cognitive health and overall brain function. Research has shown that lifestyle factors such as physical exercise, mental stimulation, and a healthy diet can help maintain both the integrity of gray and white matter as we age. Exercise. Regular physical activity has been shown to boost the growth of gray matter, improving cognitive function, and preserve white matter, enhancing brain connectivity. This is one reason why exercise is often linked to better memory, decision-making, and overall brain performance. Mental stimulation. Engaging in cognitively demanding activities like learning a new language, playing a musical instrument, or solving puzzles helps strengthen gray matter. These activities can promote neurogenesis, the growth of new neurons, and support long-term memory and learning. Diet. Nutrients like omega-3 fatty acids, antioxidants, and B vitamins have been shown to support brain health by preserving both gray and white matter. For example, omega-3s, found in fish, flax seeds, and walnuts, are crucial for maintaining the myelin sheath in white matter, which allows for faster communication between brain regions. Final thoughts on the gyrus, sulcus, and brain matters. In the grand architecture of the brain, gyri and sulci create the complex, folded surface that allows for higher cognitive functions to occur. The gray matter is where all the thinking, memory, and decision-making happens, while the white matter serves as the brain's internal communication network, ensuring everything is connected and working in harmony. Understanding the delicate balance between these structures can help us appreciate how remarkable the human brain truly is, and how, with the right lifestyle choices, we can continue to nurture and protect these neural pathways for a lifetime of optimal brain function. In short, our brains are truly masterpieces of nature's design, complex, efficient, and always adapting. So, next time you think about the brain, picture a city of neurons, with gyri and sulci creating a vast network of high-speed highways, and gray and white matter working together like the powerhouse of information processing and communication that it is. 4. Prefrontal lobe, the creative center. The prefrontal cortex, often hailed as the CEO of the brain, is where your executive functions live. Those higher-level thinking skills that allow you to plan, solve problems, make decisions, and control your impulses. Imagine it as the controls tower of an airport, coordinating the takeoffs and landings of your thoughts, ideas, and actions, ensuring everything runs smoothly. This part of your brain is also deeply involved in your creativity and ability to think abstractly, making it essential for innovation, problem-solving, and even personal growth. Artists, creatives, and the brain. Difference in the prefrontal cortex? So, what about artists or creatives? Do they have a different prefrontal cortex? While we can't say for sure that artists have a physically larger, distinct prefrontal lobe, research has suggested that creative individuals might have subtle differences in how their brains function, particularly in the way different regions of the brain connect and interact. For instance, studies have shown that artists, whether they're painters, musicians, or writers, often exhibit increased neural connectivity between the prefrontal cortex and other regions associated with creative thinking. This suggests that their brains might be more efficient at synthesizing ideas and integrating different concepts to come up with innovative solutions. It's not necessarily that their prefrontal cortex is physically larger, but the connections within it may be more active or efficient. This ability to bring together seemingly unrelated ideas could explain the creative spark that allows them to craft original works of art or find new solutions to complex problems. For example, musicians and visual artists often show heightened activation in brain regions associated with imagination and spontaneity, suggesting that they have a more flexible approach to thinking. This could mean that creativity doesn't just come from the size of your brain, but from how well it coordinates and reorganizes its resources to think in innovative ways. The prefrontal cortex and executive functions. The mental architect. The prefrontal cortex is like the architect of your mind, coordinating all the processes that enable you to make decisions, plan ahead, solve problems, and think creatively. Some of its key functions include decision making. When you are faced with a choice, whether it's choosing between 2 job offers or picking a dinner spot, the prefrontal cortex weighs the options and considers future consequences. It's your internal advisor, helping you make decisions that align with your long-term goals. Planning and reasoning. This part of your brain is responsible for organizing your thoughts and creating a strategy for achieving goals. Think of it as the blueprint designer, ensuring each step towards your objective is laid out methodically, anticipating possible obstacles and adjusting as needed. Problem solving. The prefrontal cortex allows you to approach problems from multiple angles, whether you are trying to solve a complex math problem or figuring out how to fix something that's broken. This part of the brain is working hard to find the best solution. It's like having a detective in your mind, piecing together the clues and coming up with a way forward. Impulse control. This function is critical for managing your emotional responses and inhibiting impulsive actions. Think of the prefrontal cortex as your brake pedal. It helps you pause and make rational choices rather than acting purely on instinct. Developmental aspects. The late bloomer. One fascinating aspect of the prefrontal cortex is its late development. While other regions of the brain mature early, the prefrontal cortex doesn't fully mature until your mid-20s. This explains why teenagers and even some young adults struggle with things like impulse control, making long-term plans, and managing emotions. The prefrontal cortex takes years to refine its network of connections, growing increasingly adept at handling complex tasks and helping you navigate adult responsibilities. This slow maturation process is why young adults often display inconsistent behavior. Their brain's ability to anticipate consequences and regulate emotions is still developing. By the time they hit their 30s, the prefrontal cortex is much better equipped to make thoughtful decisions and plan for the future. Creativity and innovation, turning ideas into reality. Let's talk about one of the prefrontal cortex's most exciting functions, its role in creativity. Creativity isn't just about painting or writing poetry, it's the brain's ability to think flexibly, imagine the impossible, and generate new ideas or solutions. The prefrontal cortex helps you break away from the traditional thinking patterns, making it the birthplace of innovation. Here's how it works. Flexible thinking. The prefrontal cortex allows you to switch between different ideas, concepts, and perspectives. When you are working on a problem or brainstorming for a new project, this brain region helps you think beyond conventional solutions, encouraging you to try new approaches. It's like having an all-terrain vehicle for your thoughts, able to navigate through obstacles and explore uncharted mental territory. Innovation. The prefrontal cortex is responsible for synthesizing information and combining knowledge in creative ways. It's like a chef mixing ingredients to create a completely new dish. Innovators take existing ideas and put them together in novel ways to create something groundbreaking. This capacity to connect the dots differently is what allows new inventions, artworks, and ideas to emerge. Manifestation. The brain's role in bringing thoughts to life. Manifestation is often presented as a mystical process, believing that you can bring your dreams into reality simply by focusing on them. While the concept of manifestation might sound abstract, there is a strong cognitive basis for it, particularly involving the prefrontal cortex. Manifestation involves focusing on your goals, visualizing success, and setting a clear intention to achieve what you desire. While this process might sound like wishful thinking, it's deeply connected to how the prefrontal cortex functions, particularly in goal setting and visualization. How the prefrontal cortex helps with manifestation. Goal setting and planning. The prefrontal cortex is essential for setting and breaking down long-term goals. It helps you map out a plan, set specific action steps, and anticipate obstacles along the way. It's like having a project manager in your brain, making sure each piece of the puzzle fits into place. Visualization. One of the core components of manifestation is visualizing your desired outcome. When you vividly imagine achieving your goals, whether it's getting that promotion or completing a creative project, your prefrontal cortex is activated. It works alongside other regions involved in memory and motor planning to simulate the experience, which boosts your motivation and confidence. Decision making. The prefrontal cortex plays a central role in helping you make decisions that align with your goals. Whether it's staying focused on your dream or resisting distractions, it ensures that you take actions that will bring you closer to achieving your desired outcome. It's like having a GPS guiding you in the right direction, always reminding you of the bigger picture. Thus, the prefrontal cortex doesn't just help with logical thinking and impulse control, it's essential for manifesting your desires. By setting clear goals, visualizing success, and making aligned decisions, This part of the brain helps turn your aspirations into tangible outcomes. The prefrontal cortex and decision-making. The Iowa gambling task. One of the most famous studies related to the prefrontal cortex and its involvement in decision-making is the Iowa gambling task, IGT, conducted by neuroscientist Antoine Bechara and his team in the late 1990s. This study provided groundbreaking insights into how the prefrontal cortex helps us make decisions, particularly in situations involving risk and uncertainty. In the IGT, participants are asked to choose cards from 4 different decks, each with varying levels of risk and reward. Some decks offer high immediate rewards but also higher penalties in the long run, known as bad decks, while others provide lower immediate rewards but more consistent gains over time, good decks. The goal is to maximize profits by choosing the good decks that provide sustainable rewards. What makes this task so fascinating is that the participants aren't told which decks are good or bad. Instead, they must learn over time through trial and error. Successful decision makers are those who gradually stop choosing from the bad decks and start selecting the good ones, essentially learning from their mistakes and using anticipatory emotional signals to guide future decisions. Findings and the role of the prefrontal cortex. Bechara's study revealed a fascinating connection between the prefrontal cortex and risky decision-making. Participants with damage to the ventromedial prefrontal cortex, VMPFC, a specific part of the prefrontal cortex, struggled significantly with the task. Even though they could articulate the right choices, choosing from the good decks, they continued to select from the bad decks, leading to poor outcomes. The reason? The VMPFC plays a crucial role in emotion-based decision-making. In individuals with damage to this area, the brain struggles to process the emotional signals that should warn them of the negative consequences of a choice. This lack of emotional feedback leads to poor decisions, even if the individual knows rationally that a certain choice is suboptimal. The study showed that emotion and reason work hand in hand in decision-making. While the prefrontal cortex is responsible for the rational analysis of risk and reward, the ventromedial prefrontal cortex integrates emotional responses that help us avoid risky decisions. This balance is key for creativity as well, where emotional input often guides spontaneous thinking and problem solving, allowing you to come up with creative ideas by assessing potential outcomes in real time. Implications for creativity. The Iowa gambling task is a prime example of how the prefrontal cortex, particularly in its ventromedial region, is involved in assessing risk, learning from experience, and adapting behavior. Creative thinking often requires a similar type of decision-making process, navigating between different approaches, taking risks, and being open to failure as part of the trial and error process. In fact, the study suggests that a well-functioning prefrontal cortex, especially one that can balance rational thinking with emotional insights, may be crucial for both creative problem-solving and for navigating the risks inherent in creativity. Innovators, artists, and entrepreneurs often make decisions that involve uncertainty and ambiguity, traits the prefrontal cortex is particularly good at managing. Takeaway from the study. This study highlights the remarkable role of the prefrontal cortex in decision-making, showing that it's not just about logic, but also about emotional feedback, which is essential for evaluating risk and reward. For creative individuals, this ability to balance reason with intuition can help fuel innovative thinking and adaptability, key traits for anyone working in a field where new ideas are constantly being generated. In summary, the prefrontal cortex is the brain's creative powerhouse, responsible for everything from decision-making and goal-setting to innovation and problem-solving. It's where creativity and abstract thinking come to life, allowing you to connect ideas in new ways and solve complex challenges. For artists and creatives, this area may play a particularly vital role, enabling them to think flexibly, innovate, and create works that push boundaries. Whether you are making plans, coming up with the fresh ideas, or manifesting your dreams, the prefrontal cortex is there, guiding you every step of the way. It's the mental architect, the creative force, and the strategic planner, making sure that your thoughts and actions align with your goals, bringing your ideas into the world. 5. Neuroplasticity, how it works. Imagine your brain as a sprawling city with a vast network of roads connecting different neighborhoods, regions of your brain. These roads represent the neural pathways that carry information from one part of your brain to another. Now, what if some of these roads became blocked due to a construction error, or even a car crash? A well-designed city would reroute traffic, repair the damaged roads, and create new ones to keep everything flowing smoothly. This incredible adaptability in our brains is called neuroplasticity, the ability of the brain to reorganize itself, form new connections, and change in response to experience, learning, or injury. Neuroplasticity is like the brain's self-improvement program. It's a process that allows our brain to adapt and grow, whether we are learning a new skill, recovering from a brain injury, or simply changing our behavior. The more you use your brain, the more you train it to forge new pathways, reinforcing the idea that what you do today shapes the brain you will have tomorrow. Types of neuroplasticity. There are two main types of neuroplasticity that define how our brains change and adapt over time: functional plasticity and structural plasticity. Each works in its own unique way to keep your brain flexible and efficient, like a skilled architect redesigning a building to fit new purposes. 1. Functional plasticity, the brain's backup system. Functional plasticity is like the brain's emergency plan. It's the ability of the brain to move functions from damaged areas to undamaged areas. Imagine you are in a car accident and one of the roads in your city is damaged. Instead of leaving that area inaccessible, the traffic routes are adjusted, and new paths are created to ensure everything keeps running. The brain works similarly when an area is damaged, say after a stroke or a traumatic injury. For example, if the part of the brain responsible for speech is damaged, functional plasticity allows the brain to recruit other regions, sometimes on the opposite side, to take over the task of language. This is why some stroke victims are able to regain speech over time. They are harnessing the brain's backup plan. This process can take time and rehabilitation, but it showcases the brain's extraordinary adaptability. It's a bit like learning how to navigate around a roadblock by finding an alternative route, and over time that alternative route becomes more efficient. 2. Structural plasticity, rebuilding the brain's architecture. While functional plasticity focuses on moving tasks around, structural plasticity involves the physical reorganization of the brain's architecture. It wires and circuits in response to learning, experience, or environmental changes. This means that just like an expanding city that needs new buildings and roads, the brain physically changes its structure to accommodate new information and experiences. This can involve the growth of new neurons, a process called neurogenesis, or the strengthening of existing synapses, the connections between neurons. Neurogenesis primarily occurs in the hippocampus, a part of the brain involved in memory and learning, but synaptic strengthening happens throughout the brain. The more you practice a skill or engage in a mental challenge, the more robust the connections between neurons become, making communication between brain cells faster and more efficient. For example, a study by neuroscientist Eric Kandel found that learning new tasks, like playing an instrument or juggling, can physically increase the number of synapses in the brain. Essentially, by learning something new, you are building new roads in your mental city, making the brain's pathways more complex and efficient. Neuroplasticity is a constant process, like constant road construction and upgrades, as long as you keep using your brain. Critical periods. Windows of opportunity. Just like a city undergoes major growth phases, your brain has critical periods during development, windows of time when it is especially receptive to new learning. One of the best known examples of this is language acquisition in early childhood. Babies' brains are highly flexible and primed to absorb new sounds, words, and grammar patterns. This critical period for language development is why young children can learn multiple languages much more easily than adults. It's as if their brains are wide open to new information, soaking it in like a sponge. However, critical periods aren't just limited to early childhood. There are also windows during adolescence and even adulthood when the brain is particularly responsive to new experiences or changes. For example, the teenage years are a time when the brain is going through a lot of changes and reorganizations, particularly in the prefrontal cortex. Interestingly, researchers are now discovering that adults can continue to harness the power of critical periods. A study published in Nature Reviews Neuroscience shows that adults can increase neuroplasticity by engaging in activities like learning new skills, meditation, or physical exercise, which help keep their brains in a state of flexibility. Factors that influence neuroplasticity. Neuroplasticity isn't just something that happens naturally. It's deeply influenced by several factors. Much like the growth of a city depends on its environment, resources, and the effort people put in to developing it. 1. Age. While the brain is more plastic in childhood, the ability to reorganize itself continues into adulthood. However, as we age, the brain's plasticity naturally slows down. Still, research shows that older adults can still form new neural connections if they engage in the right activities. It's like renovating an old building. It's more challenging, but entirely possible with the right tools. 2. Environment. A rich, stimulating environment can enhance neuroplasticity. For example, cognitive enrichment, such as learning a new language, practicing an instrument, or solving puzzles, has been shown to boost the growth of new neurons and improve cognitive function. Your environment acts like the urban planners of your brain. If you challenge it with novel stimuli, your brain will respond by adapting and strengthening itself. 3. Physical exercise. Exercise stimulates the production of brain-derived neurotrophic factor, BDNF, a protein that supports the growth and maintenance of neurons. Regular exercise encourages neurogenesis, helping to build new brain cells and improve overall brain function. In other words, exercise is like laying down new, efficient highways in your brain that improve its ability to process information. 4. Mental exercise. Just like your muscles, your brain gets stronger the more you use it. Regularly engaging in mental challenges like reading, learning new skills, or doing puzzles increases synaptic connections and enhances brain plasticity. It's like weightlifting for your mind, challenging it to adapt, grow, and change in response to your efforts. 5. Sleep and nutrition. Both sleep and nutrition play critical roles in neuroplasticity. Sleep helps consolidate memories, reorganize brain connections, and remove waste products from the brain. On the other hand, a balanced diet rich in nutrients like omega-3 fatty acids, vitamins, and antioxidants support brain health and promotes neurogenesis. Think of sleep as your brain's overnight renovation team, working while you rest to improve and strengthen your brain structure. In summary, neuroplasticity is the brain's way of constantly remodeling itself, forming new neural connections in response to experiences, learning, and even injury. Whether it's reorganizing functions after damage, strengthening connections with practice, or reshaping itself in response to environmental changes, neuroplasticity ensures that your brain remains adaptable and resilient. So, if you want to build a stronger, smarter brain, think of your experiences as the tools and your efforts as the construction crew. With the right resources, your brain will continue to grow, adapt, and evolve throughout your life. 6. Wave energies and brain activity. Imagine the brain as an orchestra. where neurons are the musicians and the electrical signals they generate are the music. Each neuron, like an instrument, plays in harmony with others, creating different rhythms, tones, and harmonies. These musical patterns are what we call brainwaves. They reflect the electrical activity happening in your brain at any given moment. Just like the tempo of a song can set the mood or the intensity of a scene in a movie, the frequency of these brainwaves influences how we think, feel, and perceive the world. Brainwave activity is typically classified into 5 main types, each associated with a different state of consciousness or mental activity. These brainwaves are measured by their frequency, how fast or slow the neurons fire, creating different patterns of electrical energy. The interesting thing is that just like a song can switch between soft verses and intense choruses, your brain can shift between these states depending on your activity and mental state. The 5 main types of brainwaves. 1. Delta waves, 0.5 to 4 Hertz. Deep sleep and restorative states. Delta waves are like the deep bass of the brainwave spectrum, slow, low, and powerful. They occur when you are in deep sleep, the kind that allows your body to heal, restore, and recharge. Think of delta waves as the background hum of a busy factory when all the machines are at rest, but vital processes are still taking place. These waves are linked to unconscious states, and they are critical for physical healing and memory consolidation. Without delta waves, our brains and bodies wouldn't be able to fully recover or refresh overnight. 2. Theta waves, 4 to 8 Hertz. Creativity and meditation. Theta waves are the soft, flowing melody of the brain. They occur when you are in a deeply relaxed state, such as light sleep, deep meditation, or creative flow. These waves are associated with moments of insight and creativity, when you feel like ideas are flowing effortlessly or when you are deeply connected with your emotions. Imagine the feeling of drifting in and out of sleep, where your mind is free from the constraints of everyday thoughts and worries. It's in this state that we can tap into our most imaginative, intuitive, and emotionally insightful selves. Theta waves are what make creative breakthroughs feel so effortless, as they help the brain access deeper, more intuitive levels of thought. 3. Alpha waves, 8 to 12 Hertz. Calm and focused relaxation. Alpha waves are like the steady rhythm in the background of a peaceful song. They are present when you are awake, yet in a relaxed, calm state. Think of meditating or being in a moment of quiet reflection. Alpha waves signify a balance between relaxation and alertness, where you are calm but still aware of your surroundings. This wave state is the sweet spot for learning, as your brain is open to new information but not overwhelmed by stress. The brain in alpha mode is not overloaded, yet it's still attentive, making it perfect for activities like reading, listening to music, or soaking in information during a relaxing moment. 4. Beta waves, 12 to 30 Hertz. Active thinking and problem solving. Beta waves are the fast-paced, high-energy rhythm that represents active thought, concentration, and alertness. Think of them like the rapid tapping of drums during an intense scene in a movie. When you are focused on solving a problem, making decisions, or engaging in a conversation, your brain produces beta waves. While they are essential for cognitive tasks, high beta waves can also be linked to stress and anxiety, especially when your brain is overactive or when you are feeling overwhelmed. When you are in beta mode, your mind is sharp and alert, but too much in this state can lead to mental fatigue. It's the mental gear for active work, but it needs balance with the more relaxed state to avoid burnout. 5. Gamma waves, 30 to 100 Hertz. Peak cognitive function. Gamma waves are the fastest of the brainwave frequencies, and they represent moments of intense mental activity. These are the high-pitched, energetic notes in the orchestra, associated with heightened cognitive functioning, memory recall, and the processing of information. When you are having an aha moment or feeling completely immersed in a task, your brain is likely producing gamma waves. They are linked to higher learning, creative problem solving, and even moments of spiritual insight or peak concentration. Gamma waves reflect the brain's ability to process information at a rapid pace, integrating new insights or learning in real time. How does the brain stay in tune with these wave energies? The brain, like an orchestra, doesn't play these waves randomly. It tunes itself to the right frequency based on the activity, mental state, and environmental factors you are engaging with. Just as a musician adjusts the tone of their instrument based on the song they are playing, your brain adapts to the needs of your mental environment. Neuroplasticity, the brain's ability to adapt and change. Neuroplasticity, the brain's ability to reorganize and form new neural connections, plays a crucial role in how your brain can shift between these wave states. When you practice meditation or engage in problem solving, your brain becomes more efficient at switching between these states. It's like the brain is building new neural highways to make it easier to enter a state of relaxation or focus, depending on what you need. For example, when you practice meditation regularly, your brain becomes better at producing alpha and theta waves, making it easier to access states of deep relaxation or creative flow when you need them. If you are constantly working under stress, your brain might find it harder to move out of high beta waves, keeping you in a heightened state of alertness. This is why training your brain, whether through mindfulness, yoga, or learning new skills, can enhance neuroplasticity and help you move between different brain wave states more effectively. Neurofeedback, training your brain waves. Neurofeedback is a technique that allows individuals to train their brain waves by providing real-time feedback about their brain's electrical activity. Think of it like learning to play an instrument, where you can see if you are in tune with the desired frequency. If you want to increase your alpha waves for relaxation or beta waves for focus, neurofeedback helps you visualize your brainwave patterns and learn to adjust them consciously. Over time, the brain can learn to produce more of the desired waves naturally, much like a musician improving their skills after repeated practice. This can lead to better relaxation, focus, and cognitive performance without the need for external devices or distractions. External stimuli, sound and light as brainwave modulators. External factors, such as sound and light, can also influence brainwaves. For example, binaural beats are auditory tones that play two slightly different frequencies in each ear. The brain perceives a third, unique frequency which can encourage it to enter a specific wave state. Alpha binaural beats can promote calm and focus, while theta binaural beats might help you relax deeply or tap into your creativity. Similarly, light therapies like bright light exposure or flashing lights at certain frequencies can influence brainwaves, promoting relaxation, focus, or creativity. These environmental cues act like conductors of an orchestra, helping the brain synchronize its activity with the desired state. In summary, brainwave activity is the language of the brain, the rhythms and frequencies that dictate our mental states, from deep sleep to peak cognitive function, just like an orchestra shifting from a peaceful melody to a dramatic crescendo. The brain tunes itself to different frequencies based on what it needs at the moment. Whether you are in deep rest with delta waves, exploring a creative flow with theta waves, or tackling a problem with beta waves, your brain is constantly shifting and adapting. Through techniques like neuroplasticity, neurofeedback, and external stimuli, such as binaural beats or light therapies, you can help your brain tune itself to the waves that best serve your goals, whether that's relaxation, focus, or insight. Your brain is a flexible, adaptive instrument, always ready to change its tune, depending on what's needed. So why not make sure it's playing the right rhythm for you? 7. Nutrients your brain needs to function at a high level. Think of your brain as a high-performance machine, an intricate network of circuits and connections working together to process, store, and communicate information. Just like any finely tuned engine, it requires specific fuels to run smoothly. Nutrients are that fuel for your brain. These nutrients don't just support day-to-day operations. They're the very building blocks that help your brain learn, adapt, think clearly, and even repair itself when necessary. Imagine you are assembling a complex puzzle. The pieces are all there, but without the right tools, precision, alignment, and time, putting it together would be impossible. Similarly, the right nutrients act as the tools, helping your brain assemble and maintain the complex web of thoughts, memories, and skills. Let's break down some of the key nutrients that play a vital role in keeping the system running at its best. The brain's checklist: high level versus base level functioning. Before diving into the specifics of the nutrients your brain needs to function at its best, let's start with a scientifically backed framework for understanding what the brain requires to operate at a high level versus just getting by at a base level. Think of the brain as a car. At a base level, a car can run on low-grade fuel. It will get you from point A to point B, but you won't be breaking any speed records or taking sharp turns with ease. To perform at a high level, however, the car needs premium fuel, maintenance, and optimal conditions. The brain works the same way. When you give it the right inputs, it performs better in all aspects, whether that's solving complex problems, staying focused for hours, or being emotionally resilient. What does the brain need to perform at a high level? At a high level of function, the brain is sharp, adaptable, and resilient. It's able to perform tasks like learning new skills, managing stress, problem-solving efficiently, and maintaining mental clarity under pressure. To achieve this, the brain requires: Number 1, sustained efficient energy. Your brain consumes more energy than any other organ, accounting for around 20% of your total energy expenditure. The brain's neurons need a steady supply of glucose and oxygen to fuel cognitive function, which is why a consistent supply of high-quality nutrients is so crucial. 2. Neuroplasticity support. The brain's ability to form and strengthen new connections even into old age. High-level function depends on the brain's ability to reorganize and form new neural pathways quickly in response to learning, problem-solving, and environmental challenges. 3. Optimal communication between neurons. Effective communication is essential for processing information and transferring data across the brain. Neurotransmitters like dopamine, serotonin, and acetylcholine must be in balance, ensuring smooth communication between brain cells. 4. Cognitive flexibility. The ability to switch between tasks, solve complex problems, and adapt to new situations. This requires not only neural flexibility but also the right balance of nutrients and support for key brain regions like the prefrontal cortex. 5. Protection against inflammation and oxidative stress. Chronic inflammation and oxidative damage can wear down the brain over time, impairing memory, focus, and cognitive performance. A high-functioning brain requires robust protection against these stressors. 6. Emotional regulation and stress management. The high-functioning brain can manage both external and internal stressors, keeping emotions in check and maintaining a positive mindset. This involves the hippocampus, amygdala, and other regions working together seamlessly. What does the brain need to function at a base level? At the base level, your brain can still perform basic functions, such as walking, breathing, and processing information to get through everyday tasks, but it's likely sluggish, less adaptive, and may struggle with challenges like stress, focus, and memory. The brain, like a car running on low-quality fuel, will manage to get through the day but won't excel. To operate at this baseline: 1. Minimal energy supply. The brain still requires energy, but it may struggle to access sufficient fuel sources, leading to mental fatigue, poor concentration, and low motivation. 2. Basic neuroplasticity. The brain may still be able to form some new connections and memories, but it's much slower and less efficient in response to learning or environmental stimuli. 3. Imbalanced neurotransmitter activity. Communication between brain cells becomes inefficient, leading to issues with focus, mood regulation, and cognitive flexibility. You may find it difficult to concentrate or feel mentally foggy. 4. Impaired cognitive flexibility. Switching between tasks or solving complex problems becomes challenging. You might feel overwhelmed when faced with new or unexpected situations. 5. Heightened vulnerability to stress. The brain is less equipped to handle prolonged stress, making it more likely to experience anxiety, irritability, or mood swings. 6. Increased inflammation and oxidative stress. The brain may experience more oxidative damage due to low intake of antioxidants or other protective nutrients, leading to cognitive decline over time. The nutrients that turn the base level into high performance. Now that we understand the brain's fundamental needs for both base and high-level functioning, let's break down the key nutrients that help elevate the brain's performance. These nutrients support everything from energy production and memory to neuroplasticity and emotional regulation. 1. Omega-3 fatty acids, DHA and EPA. Why it's important. Omega-3 fatty acids are like the lubricant for your brain's intricate machinery. DHA, docosahexaenoic acid, and EPA, icosapentaenoic acid, are essential components of the brain's cell membranes, ensuring these cells stay flexible and fluid, allowing them to communicate effectively. Think of DHA as the foundation stone of your brain's structure, maintaining the integrity and function of the neurons, while EPA works to reduce inflammation and protect the brain from damage. Without these fatty acids, brain cells become stiff, communication slows, and cognitive abilities start to decline. Sources: fatty fish, salmon, mackerel, sardines. Plant-based sources like flax seeds, chia seeds, and walnuts. Algal oil, a plant-based DHA source for vegans. Scientific insight. Research consistently shows that omega-3s help improve memory, focus, and protect against neurodegenerative diseases. For instance, a study in the American Journal of Clinical Nutrition highlighted that individuals with higher omega-3 levels had improved cognitive function and a lower risk of conditions like Alzheimer's disease. The brain thrives on these healthy fats, which reduce inflammation and keep mental processes sharp as you age. 2. Antioxidants, vitamins C and E, polyphenols. Why it's important. Your brain needs defense against free radicals, unstable molecules that can damage your brain cells. This is where antioxidants come in. They act as the protective barriers, neutralizing free radicals and preventing oxidative stress. Without this defense, brain cells age prematurely, leading to cognitive decline and neurodegenerative diseases. Antioxidants are like the brain's immune system, constantly working to repair and shield from the damage of daily life. Sources: vitamin C, citrus fruits, strawberries, bell peppers. Vitamin E, almonds, sunflower seeds, spinach. Polyphenols: blueberries, dark chocolate, green tea, turmeric. Scientific insight. A study published in Neurobiology of Aging found that antioxidants, especially vitamin E and polyphenols, help protect against Alzheimer's disease and improve brain function by combating oxidative stress. Blueberries, in particular, have been shown to improve memory and cognitive performance in older adults, making them a natural brain booster. 3. B vitamins, B6, B12, folate. They help maintain nerve health, produce neurotransmitters, and support brain cell growth and repair. Without these vitamins, your brain might miss a beat, leading to poor memory, confusion, and even mood disorders. B6, B12, and folate work together to ensure the brain's complex network stays intact and functioning at full capacity. B6 helps produce serotonin and dopamine, critical for mood and memory. B12 is essential for maintaining healthy nerve cells and DNA. Folate is important for the growth and repair of brain cells, especially in the early stages of life. Sources: B6, poultry, fish, chickpeas, bananas. B12, meat, fish, dairy, fortified plant-based milks. Folate, leafy greens, lentils, beans. Scientific insight. Studies have shown that a B12 deficiency is strongly linked to cognitive impairment and dementia, particularly in older adults. Higher intake of B vitamins has been found to improve cognitive function and even delay age-related mental decline, according to the American Journal of Clinical Nutrition. 4. Magnesium. It helps regulate the neurotransmitter glutamate, which is involved in learning and memory. When glutamate levels are too high, it can overwhelm neurons, leading to cognitive exhaustion or damage. Magnesium keeps everything in check, ensuring that neurotransmitter activity is balanced. It also supports synaptic plasticity, which is the ability of neurons to adapt and form new connections. Think of magnesium as a stabilizing force, keeping the brain flexible and resilient. Sources: leafy greens, spinach, kale. Nuts, almonds, cashews. Seeds, pumpkin, sunflower. Dark chocolate, high in cacao. Scientific insight. Research in Frontiers in Aging Neuroscience has demonstrated that magnesium supplementation can improve memory and reduce cognitive decline in aging adults. Magnesium also plays a crucial role in sleep regulation, which is essential for brain repair and learning. 5. Zinc. Zinc is involved in learning and memory, ensuring that brain cells are communicating and adapting to new information. Zinc is also essential for the immune system and acts as a powerful antioxidant, protecting the brain from free radical damage. Sources: shellfish, especially oysters, red meat, poultry. Beans, nuts, seeds, whole grains. Scientific insight. Low zinc levels have been associated with cognitive deficits and an increased risk of neurodegenerative diseases. Research published in Neuropsychopharmacology has shown that zinc supplementation can improve memory and learning abilities, especially in individuals with deficiencies. 6. Vitamin D. Vitamin D is often called the sunshine vitamin, but it does more than just regulate calcium levels. It acts like a gatekeeper for your brain's immune system, regulating genes involved in the brain's defense mechanisms. When vitamin D is low, the brain becomes more vulnerable to inflammation and damage, increasing the risk of depression, cognitive decline, and even Alzheimer's disease. Think of vitamin D as your brain's shield, protecting it from the wear and tear of aging. Sources: sunlight exposure, fatty fish, salmon, mackerel, fortified dairy products, fortified plant-based milks. Scientific insight. A study in the Journal of Clinical Endocrinology and Metabolism found that low vitamin D levels are associated with a higher risk of cognitive decline and depression. Supplementing vitamin D has shown improved mood and cognitive function, particularly in older adults. 7. Protein. Amino acids. Proteins, broken down into amino acids, are the building blocks of neurotransmitters, chemicals that allow communication between brain cells. Neurotransmitters like dopamine, serotonin, and acetylcholine are vital for mood regulation, memory, and cognitive function. Without adequate protein, the brain can't produce enough for these neurotransmitters, leading to brain fog, low energy, and difficulty concentrating. A steady supply of protein ensures that the brain has what it needs to keep functioning at its best. Sources: lean meats, fish, eggs, dairy. Legumes, nuts, seeds, soy products. Scientific insight. A study in Neurochemistry International showed that a high-protein diet supports better brain function by providing the amino acids needed for neurotransmitter synthesis. This is especially important for mood regulation and cognitive performance. Conclusion. Your brain is a high-performance machine, and just like any top-tier engine, it requires the right fuel to operate at its peak. Omega-3 fatty acids, antioxidants, B vitamins, magnesium, zinc, vitamin D, and protein are all essential for maintaining optimal brain function. These nutrients support the brain's structure, energy supply, communication, and protection, improving memory, focus, mental clarity, and emotional regulation. By prioritizing these nutrients in your diet, you are setting the stage for enhanced cognitive function and resilience, helping to protect against cognitive decline as you age. When these nutrients are lacking, the brain operates at a base level, struggling with poor memory, concentration, and mood regulation, and is more vulnerable to stress, fatigue, and long-term cognitive decline. Fueling your brain with the right nutrients doesn't just help you think more clearly today, it protects your mental health for years to come. 7. Recommended brain exercises that I like to practice: puzzles, reading, and chess. Engaging in regular mental exercises is one of the best ways to keep your brain sharp, improve cognitive function, and enhance overall brain health. Just like how a muscle needs regular training to stay strong, your brain thrives on activities that challenge it and keep it active. Below are 3 activities I personally enjoy and highly recommend, along with the science-backed benefits they provide. Puzzles. A fun way to boost problem-solving skills. Benefits. Puzzles, whether crosswords, Sudoku, jigsaw puzzles, or logic problems, are like a gym for your brain. They engage various regions of your brain and challenge it to think critically, solve problems, and make connections. Puzzles promote neuroplasticity, the brain's ability to form new neural connections, improving short-term and long-term memory, spatial reasoning, and cognitive flexibility. Science behind it. Cognitive flexibility and memory. A 2019 study in the Journal of Applied Gerontology found that regular engagement with puzzles helped older adults improve cognitive flexibility, the ability to adapt to new and unexpected situations, and processing speed. This means puzzles may slow down the natural cognitive decline that occurs with aging. Neuroplasticity and brain health. Puzzles stimulate multiple brain areas, including the hippocampus, which is key for memory, and the prefrontal cortex. Regular practice of mentally challenging activities like puzzles can preserve brain health and increase cognitive resilience. Jigsaw puzzles, a deep dive into cognitive benefits. Jigsaw puzzles are deceptively simple, but pack a punch when it comes to cognitive benefits. When you work on a jigsaw puzzle, you are actively engaging in problem solving, memory recall, and spatial reasoning. You are mentally and physically putting together a complex picture, piece by piece. It's like assembling a jigsaw of your brain's ability to connect the dots, literally. Science behind it. Enhancing problem-solving skills. When you're piecing together a jigsaw puzzle, your brain is evaluating spatial relationships, identifying patterns, and testing hypotheses. Just like a detective solving a mystery, research from the Journal of Experimental Psychology suggests that activities like puzzles improve spatial reasoning and visual processing. You are training your brain to solve problems, which transfers to real-life situations, like navigating a new city or troubleshooting an issue at work. Boosting memory and cognitive function. Jigsaw puzzles require remembering patterns, shapes, and colors, giving both short-term and long-term memory a workout. A 2016 study published in Frontiers in Psychology found that tasks like jigsaw puzzles enhance spatial memory and visual processing by requiring the brain to actively recall details and assemble pieces from memory. Improving spatial awareness. Jigsaw puzzles boost visual spatial reasoning, the ability to understand and remember the relationships between objects in space. In psychological science, researchers found that those who engage in tasks like puzzles tend to perform better at mental rotation and spatial judgment, essential skills for navigation, engineering, and architecture. Concentration and focus. Jigsaw puzzles force the brain to stay focused for long periods, honing your attention span and concentration. The act of solving the puzzle filters out distractions, training the brain to focus better on other tasks. A study in Neuroimage highlighted that tasks requiring sustained concentration, like puzzles, improve cognitive control, which translates into better focus in everyday life. Stress relief and relaxation. Solving a puzzle is also meditative, lowering cortisol, the stress hormone, and promoting relaxation. It offers a mental break and helps you to unwind. 2013 study in the Journal of Occupational and Organizational Psychology found that engaging in activities that require focused attention, like puzzles, reduces stress levels and fosters a calm state of mind. Reading, the brain workout for knowledge and focus. Benefits. Reading is one of the most effective ways to give your brain a workout. Whether you are diving into a fiction or nonfiction, reading stimulates the brain on multiple levels. It enhances memory, comprehension, vocabulary, and emotional processing. It's like a mental gym that flexes your brain's muscles for both intellectual and emotional growth. Science behind it. Cognitive reserve and memory. Research published in neurology shows that individuals who engage in mentally stimulating activities like reading have a higher cognitive reserve, which helps delay the onset of age-related neurodegenerative diseases like Alzheimer's. A study from the Proceedings of the National Academy of Sciences found that frequent reading improves long-term memory by challenging the brain to retain and process new information. Focus and emotional processing. Reading, especially fiction, enhances empathy and emotional intelligence. A study in Science demonstrated that reading literary fiction increases a person's ability to understand and empathize with others' emotions. Characters in novels or stories often force the reader to consider diverse perspectives, sharpening emotional insight and attention. Chess, a strategy game for enhancing cognitive function. Benefits. Chess is more than just a game. It's a full mental workout. Every move requires strategic planning, critical thinking, and memory recall. Chess builds executive functions like problem solving, attention, and cognitive flexibility. It's like a mental marathon that keeps your brain agile and ready to solve complex problems. Science behind it. Memory and strategy. A study published in the Journal of Neuroscience found that regular chess play enhances both working memory and fluid intelligence. Chess requires players to remember moves, plan ahead, and juggle multiple strategies at once, skills that are crucial for cognitive flexibility. Cognitive performance and aging. Research from the New England Journal of Medicine suggests that engaging in cognitively stimulating activities like chess can help protect against cognitive decline in older adults. Another study in Frontiers in Psychology found that chess players exhibited improved cognitive flexibility, working memory, and processing speed. Concentration and problem solving. Chess improves concentration and helps you stay mentally sharp. The game forces players to focus for long periods and to think critically, strengthening problem-solving abilities. Chess players often show superior problem-solving skills in real-life situations as well. Why these exercises work. Engaging in puzzles, reading, and playing chess isn't just about passing the time, it's about feeding your brain with the mental stimulation it craves. These activities support neuroplasticity, the brain's ability to reorganize itself by forming new neural connections. These activities support neuroplasticity. By regularly challenging your brain, you are ensuring that it remains active, adaptable, and sharp, which is key for long-term cognitive health. Whether it's improving problem-solving skills through puzzles, enhancing emotional intelligence through reading, or boosting strategic thinking with chess, these exercises offer lasting benefits. And the best part, you don't need to be a genius to start. Just consistent practice can help your brain stay at its best at any age. Conclusion. By incorporating brain exercises like puzzles, reading, and chess into your routine, you are not only making your brain more agile and adaptable, you are also improving your memory, problem-solving skills, and cognitive flexibility. Whether you are piecing together a jigsaw puzzle, diving into a captivating novel, or outsmarting an opponent on the chessboard, these activities provide a fun and effective way to keep your brain healthy, engaged, and sharp for years to come. The science is clear. A little brain exercise goes a long way in promoting cognitive health and overall mental well-being. So, next time you reach for a book, board game, or puzzle, Know that you are not just having fun, you are also giving your brain a workout. Bonus number 1, how strength training affects the brain. When most people think about strength training, they picture bulging muscles, heavy weights, and sweat-drenched workouts. But did you know that lifting weights doesn't just build your biceps or quads, it also gives your brain a powerful workout? Strength training is like a multi-tool for your body, enhancing both physical and mental health in ways you might not expect. So, let's dive into how strength training affects the brain, and why you should add it to your cognitive health toolkit. The brain-body connection. Strength training as brain fuel. The brain and body are more connected than we often realize. Imagine your brain as the control center of a massive orchestra, and every part of your body is an instrument. When you engage in strength training, it's like you are conducting this orchestra, getting every part of your body to play in harmony. The more you strengthen your muscles, the more you are actually training your brain to become sharper, more focused, and more resilient. When you lift weights, you don't just engage your muscles, you stimulate neurogenesis, the process of creating new neurons, particularly in the hippocampus, the area of the brain responsible for memory and learning. It's as if you're building a stronger, more expansive highway for information to travel across your brain. Neuroplasticity, strength training, and brain growth. Neuroplasticity, the brain's ability to reorganize itself and form new neural connections, is like the brain's personal renovation project. Strength training is one of the most effective ways to trigger this process. How it works. When you engage in resistance exercises like squats, deadlifts, or push-ups, your body releases a flood of growth factors, including brain-derived neurotrophic factor, BDNF, a protein that acts like a fertilizer for your brain, encouraging the growth of new neurons and synapses. The more BDNF your brain produces, the stronger your brain's connectivity becomes, especially in areas related to memory, learning, and higher-level cognitive functions. Research backs this up. A study published in the Journal of Strength and Conditioning Research found that regular strength training increased levels of BDNF, which in turn was associated with improved cognitive function and memory. 2. Improved focus and attention. A cognitive boost from weights. Ever noticed that after a solid weightlifting session, you feel more alert, clear-headed, and focused? That's not just your body recovering, it's your brain benefiting from the workout too. How it works. Strength training has been shown to boost the production of dopamine and norepinephrine, neurotransmitters responsible for focus, alertness, and mood regulation. Think of these chemicals as the brain's fuel. Just like a sports car needs high-quality fuel to run smoothly, your brain needs these neurotransmitters to perform at its best. A study from the American Journal of Lifestyle Medicine found that participants who engaged in strength training showed improved executive function, which includes attention, problem solving, and the ability to switch between tasks efficiently. Essentially, lifting weights doesn't just improve muscle tone, it also sharpens your mind, making it easier to stay focused throughout the day. 3. Mood enhancement. Strength training as brain medicine. When you lift weights, your body produces endorphins, those feel-good hormones that gives you that natural high after exercise. But strength training also has a powerful effect on serotonin, a neurotransmitter linked to mood regulation, feelings of well-being, and happiness. Increasing serotonin levels can lead to reduced anxiety and an uplifted mood, which is why many people find that strength training gives them a mental boost. A study published in the Journal of Sports Medicine and Physical Fitness found that strength training was effective in reducing symptoms of depression and improving overall mood, especially in older adults. It's like hitting two birds with one stone. You are building muscle and fighting off the mental fog at the same time. 4. Stress reduction. Strength training as a stress relief tool. Stress is a natural part of life, but how you respond to it can make all the difference. Strength training is one of the most effective ways to reduce stress and enhance your brain's resilience to it. Think of your brain as a sponge. Constant stress can leave it saturated and overwhelmed. Strength training, however, acts like a ringer, releasing that built-up tension and leaving your brain in a more relaxed, balanced state. When you engage in resistance exercises, you activate your parasympathetic nervous system, which is responsible for the rest and digest response. This helps lower cortisol, the hormone associated with stress, and promotes feelings of relaxation. Additionally, regular strength training has been linked to a reduction in anxiety and a greater sense of emotional well-being. A study published in Psychology of Sport and Exercise found that resistance training was highly effective at lowering cortisol levels, helping individuals recover from stress more efficiently. It's like trading in a brain that's constantly on edge for one that can handle challenges with greater calm. 5. Cognitive aging, protecting your brain through strength training. As we age, our cognitive function tends to decline. It's just part of the natural process. However, strength training can help slow down or even reverse this decline, giving your brain a much-needed dose of vitality. How it works. Strength training increases hippocampal volume, the part of the brain responsible for learning and memory. As we get older, the hippocampus tends to shrink, which can lead to issues with memory and spatial navigation. But research shows that regular resistance exercise can slow or even prevent this shrinkage, keeping your memory and cognitive abilities sharp as you age. A 2016 study in the Journals of Gerontology found that older adults who participated in strength training showed improvements in cognitive function, especially in areas related to executive function and working memory. This highlights the powerful protective benefits of strength training, making it a key strategy for preserving brain health in later years. Conclusion: lifting weights for a sharper mind. Strength training is more than just about getting stronger muscles or building a sculpted body. It's about creating a brain that is more resilient, focused, and better equipped to handle the demands of life. By enhancing neuroplasticity, boosting mood, reducing stress, and protecting cognitive function, strength training acts as a mental elixir, keeping your brain sharp and agile. So next time you hit the gym or pick up a set of dumbbells, remember, you are not just working your muscles, you are strengthening your mind as well. With every lift, squat, and press, you are building a more powerful brain that will serve you well, not only today, but for years to come. Incorporating strength training into your routine isn't just a physical upgrade, it's a mental one too. So whether you're lifting to build muscle or to boost brain power, strength training is one of the best ways to support your mental and physical health, helping you become the best version of yourself inside and out. Bonus number 2. How music affects the brain. Let's talk about music, something we all love and often rely on for everything from setting the mood to calming our nerves. We turn on our favorite track when we are happy, sad, or somewhere in between. But have you ever wondered what's really happening inside your brain when music starts to play? It's not just an emotional experience, it's a complex dance between sound, brain waves, and your deepest thoughts. Music isn't just a pleasant distraction, it's a powerful force that impacts everything from memory to mood, creativity to cognition. But here's the twist. There's some irony to the relationship between music and the brain too. While music is often lauded for its mood-boosting and cognitive benefits, some studies suggest that overindulgence in music, especially for those using it as a coping mechanism, can actually lead to feelings of isolation and depression. Intrigued? Let's unpack it. 1. Music as a brain workout, a complex symphony of brain activity. From the emotional limbic system to the logical prefrontal cortex, music has the ability to activate several regions of the brain simultaneously, and not just in the auditory cortex, which processes sound. The prefrontal cortex gets workout, as does the hippocampus and the motor cortex. The brain's complex pattern recognition abilities are also at play, as it seeks out structures, rhythms, and melodies. Music triggers a deep mental response that keeps your brain active and engaged, much like how training multiple muscle groups in the gym keeps your body fit. Research shows that listening to music can improve various cognitive abilities. A study published in Psychological Science demonstrated that music with a strong tempo can improve cognitive performance and help you complete tasks faster. But this is where the twist comes in. Too much music, especially passive listening, just zoning out to background tunes, may reduce attention span and impact cognitive flexibility. 2. The emotional power of music, a roller coaster for your feelings. Music can be a magic elixir for your emotions. It can make you feel euphoric, nostalgic, or even melancholic. The brain's emotional centers, such as the limbic system and amygdala, are quick to respond to music's emotional cues. Have you ever noticed how certain songs can bring tears to your eyes or give you goosebumps? This is your brain and your body syncing up in an emotional tango, triggered by rhythm, harmony, or lyrics. When we hear music, the limbic system gets activated, releasing dopamine, the brain's feel-good neurotransmitter. It's like your brain's personal happiness agent, delivering that rush of pleasure when the music hits the right note. Music has been shown to reduce stress and even lower cortisol levels, the stress hormone, promoting relaxation. But the irony is, while music can be incredibly uplifting, it can also be a double-edged sword. For some people, excessive music consumption, especially in solitary contexts or when used to mask negative emotions, has been linked to depression and feelings of isolation. One study found that individuals who listen to music regularly, particularly in times of distress, may experience more intense sadness and emotional detachment. The issue lies not with the music itself, but with how people use it. Instead of using music to regulate mood healthily, over-relying on it can sometimes deepen emotional isolation. 3. Music and memory, a powerful trigger for recall. There's something about a song that can instantly take you back to a specific moment, perhaps a memory you haven't thought about in years. Music doesn't just evoke emotions, it also has a remarkable ability to trigger memories. In fact, it's often used in therapy to help people with Alzheimer's disease and other forms of dementia recall old memories. Music activates the hippocampus. In particular, songs you've heard repeatedly become embedded in long-term memory. That's why certain tunes can instantly transport you to another time and place. When you hear a familiar song, it acts like a key that unlocks the door to specific memories associated with that piece of music. It's also worth noting that music has a unique ability to enhance working memory, the short-term memory you use for tasks at hand. Studies have shown that people who listen to music while learning or studying often recall information better, likely because music helps establish stronger memory associations. However, here's where the irony appears again. For people who use music as an emotional crutch, listening to certain songs can reinforce negative memories and emotions. So while music can enhance memory recall, it can also serve as a reminder of sad or painful experiences. 4. Music and brain activity, the puzzle of pattern recognition. Here's where it gets really interesting. Music isn't just about making you feel good. It's also a serious workout for your brain's ability to recognize patterns, sequences, and structure. Whether it's the predictable rhythm of a song or the more complex melodies in classical music, your brain is constantly searching for patterns and connections in the sounds it hears. The brain is wired for pattern recognition, and music is a gold mine for this. When you listen to a song, your brain is actively predicting what comes next. It listens for patterns in rhythm, pitch, and harmony. When the pattern breaks, like an unexpected note or pause, it takes notice. This activity involves the auditory cortex as well as the prefrontal cortex and parietal lobe. Music trains your brain to become more efficient at identifying patterns, which helps with other cognitive tasks like problem solving and decision making. That's why musicians often perform better in tasks that require critical thinking. They've spent years developing these sophisticated cognitive pathways. But here's the kicker. The hyperactive pattern recognition can sometimes work against us. When you are constantly immersed in music, particularly music with repetitive, predictable patterns, your brain can become overly dependent on external stimuli to maintain focus. In contrast, silence or less stimulating environments may feel jarring or empty. It's like your brain gets used to a rhythm and then struggles to adapt when that rhythm disappears. The irony, the dark side of music consumption. As much as music has the potential to improve mood, enhance cognitive performance, and promote social bonding, the overuse of music, especially as an emotional escape, can have the opposite effect. The irony is that people who excessively use music to mask feelings of sadness or anxiety might find themselves sinking deeper into emotional isolation. Research has shown that habitual use of music for emotional regulation, when done in excess, can sometimes perpetuate negative emotions rather than alleviate them. A study published in Psychology of Music found that people who used music as a tool for emotional escapism rather than as a form of engagement reported feeling more depressed and isolated. Music, in these cases, serves as a form of self-soothing, but without real emotional connection or resolution. Conclusion. Music, a double-edged sword for the brain. So, what's the verdict on music in the brain? Music is undoubtedly a powerful force, stimulating cognitive functions, triggering memories, boosting mood, and enhancing creativity. It's a workout for the brain, engaging everything from pattern recognition to emotional processing. But like all things, balance is key. Too much of it, especially when used to avoid uncomfortable feelings, can lead to emotional numbness or detachment. Ultimately, music's impact on your brain depends on how you use it. Whether it's for cognitive enhancement, emotional expression, or relaxation, music is a tool that, when used wisely, can enhance mental well-being. But when overused as a crutch for avoidance, it can reinforce negative patterns. So, next time you press play, remember, music can be both the medicine and the ailment. It all depends on how you use it. Conclusion. Optimizing brain health and cognitive function. In summary, understanding how the brain develops, the different types of intelligence it harbors, and the specific regions that control mental functions gives us a powerful roadmap to support and enhance our cognitive abilities. The brain doesn't stop growing at a specific age. It's a lifelong journey, reaching full maturity in the mid-20s, but continuing to adapt, change, and improve. Recognizing the roles of fluid intelligence, the ability to solve new problems, and crystallized intelligence, the wisdom we accumulate over time, can help us tailor how we approach learning and problem solving at different stages of life. Key regions of the brain, such as the prefrontal cortex, are crucial in governing creativity, decision-making, and higher-level thinking. This speaks to the brain's remarkable complexity and how our mental capabilities are distributed across various areas. But perhaps one of the most exciting discoveries is neuroplasticity, the brain's ability to reorganize itself and form new connections, even in adulthood. This gives us hope that we can continue to grow and improve cognitively, regardless of age, as long as we engage in activities that challenge our brain. Speaking of brain challenges, incorporating simple yet effective exercises into our daily routine, such as puzzles, reading, and chess, can have profound benefits over time. These activities don't just engage us in fun pastimes, they serve as powerful tools to enhance cognitive function, improve memory, and develop problem-solving abilities. Whether it's the mental workout provided by a jigsaw puzzle or the strategic thinking demanded by a game of chess, these brain exercises foster neuroplasticity and sharpen our minds in ways that ripple across every aspect of life. The key takeaway here is that even the most straightforward actions, like flipping through a book, solving a puzzle, or challenging yourself with a strategy game, can lead to lasting improvements in brain health. These activities keep the mind sharp, engaged, and resilient, especially as we age. But the benefits aren't limited to seniors. Young minds also benefit from early and consistent engagement in mental exercises, paving the way for lifelong cognitive health. Understanding how our brains work, how they grow, and how they respond to stimulation empowers us to make intentional choices to optimize our mental potential. Every day is an opportunity to enhance our cognitive abilities, whether by engaging in activities that promote neuroplasticity, focusing on the fundamentals of mental fitness, or simply seeking new challenges. By committing to this continuous cycle of brain care, we ensure that our minds remain as vibrant, adaptable, and capable as ever, no matter where we are on our cognitive journey. If you enjoyed this episode, I'd love to hear your thoughts. Also, be sure to follow me on social media to stay up to date with my journey.